Antarctica. The name itself conjures images of an alien world, a place of profound isolation at the very bottom of our planet. It's a continent of superlatives, the coldest, driest, and highest on Earth. For centuries it existed only in the imaginations of ancient philosophers and the ambitious dreams of explorers, a theoretical landmass known as Terra Australis Incognita, or the unknown southern land. This vast wilderness, larger than Europe and nearly twice the size of Australia, is a kingdom of ice. An endless expanse of white stretches to every horizon, a landscape so stark and so pure that it seems to defy the very notion of life, a silent testament to the raw power of nature. In its most extreme and unforgiving form, the air here is so cold it can freeze exposed skin in an instant, and the winds, known as katabatic winds, can reach speeds of over 300 kilometers per hour. They scour the surface, sculpting the snow into bizarre and beautiful shapes called sastrugi. This is a land governed by winter, where the sun disappears for months, plunging the continent into a long, dark polar night. The silence is absolute, a deep, resonant quiet that is broken only by the howl of the wind or the distant, thunderous crack of a calving glacier. It's a place that feels utterly detached from the familiar rhythms of the world we know, a final frontier on our own planet that has guarded its secrets with a ferocity unmatched anywhere else. To stand in Antarctica is to feel humbled by the sheer scale and immensity of it all. It's a place that reshapes your perspective, making human concerns feel small and transient. The ice sheet, which covers 98% of the continent, is a colossal frozen reservoir containing about 70% of the world's fresh water. If it were all to melt, global sea levels would rise by a catastrophic 60 meters, redrawing the maps of our world. This colossal ice cap is not static. It's a slow-moving river of ice, constantly shifting, grinding, and flowing towards the sea under its own immense weight. A dynamic and powerful force that has shaped this land for millions of years and continues to do so today. For most of human history, this remote continent remained a mystery, a blank space on the map. Early sailors who dared to venture into the Southern Ocean were met with impenetrable pack ice and terrifying storms, forcing them to turn back with tales of a cursed land. It wasn't until the 19th century that humans first set foot on its shores, beginning an era of heroic exploration and scientific discovery. These early pioneers faced unimaginable hardships, battling frostbite, starvation, and overwhelming isolation. Their stories are a testament to human courage and curiosity. A relentless drive to explore the unknown, no matter the cost, and to pull back the curtain on this magnificent frozen world. For all its stark and desolate beauty, the surface of Antarctica is merely a prelude. It's a grand, theatrical curtain of white, concealing a world of profound mystery and wonder. We have long viewed this continent as a simple frozen monolith, a static and unchanging wasteland, but this perception is a grand illusion. The truth is far more complex and, honestly, infinitely more fascinating. Beneath the crushing weight of the ice, a secret geography has been locked away for eons, a hidden landscape that defies everything we thought we knew about this polar desert. The real Antarctica is not the one we see, but the one that lies unseen, buried deep beneath kilometers of ancient ice. This hidden world is not just a geological curiosity, it is a repository of Earth's ancient history. The ice itself acts as a time capsule, with each layer preserving a record of the planet's climate going back hundreds of thousands of years. Scientists drill deep into this frozen archive, extracting ice cores that contain trapped air bubbles from ancient atmospheres. By analyzing these tiny pockets of air, they can reconstruct past climates with astonishing precision, revealing the natural cycles of ice ages and warm periods that have shaped our world. But the ice hides something even more profound. An entire continent, complete with its own unique features, buried and waiting to be discovered. Imagine a world without ice. If you could peel back this colossal frozen sheet, you would find a continent of staggering diversity. You would see vast plains, deep valleys, and towering mountain ranges. The Gamburtsev Mountains, for instance, are a range as jagged and majestic as the European Alps, yet they are completely buried under 3 kilometers of ice. They were discovered not by sight, but by the faint echoes of seismic waves sent deep into the frozen crust. These ghostly mountains, which have not seen the sun for over 30 million years, raise tantalizing questions about the geological forces that formed them and the ancient world they once dominated before the ice descended. The discovery of this subglacial world has ignited a new age of exploration. It is a quest not for new lands on the surface, but for a lost continent buried below. We are like cartographers of the unseen, using sophisticated tools to map a world we can never touch directly. Every new discovery, every new data point adds another piece to this incredible puzzle. The secrets of Antarctica are not just about a single continent, they are about understanding the deep, hidden processes of our planet. They challenge our assumptions and force us to imagine a world far more dynamic and mysterious than we ever thought possible, a world that lies just beneath our feet yet is as remote as another planet. The sheer scale of the Antarctic ice sheet is, well, difficult to comprehend. In some places, its thickness exceeds 4.5 kilometers. That is a column of ice taller than the highest peaks of the Rocky Mountains. This immense weight presses down on the land beneath, depressing the Earth's crust by as much as 0.5 kilometer. For generations, this impenetrable barrier of ice led us to believe that Antarctica was a relatively flat and featureless landmass, its true topography smoothed over and erased by the relentless ice. It was a logical assumption, but one that has been proven spectacularly wrong. The White Desert is not empty, it is a mask that conceals a complex and dramatic world. To explore this hidden realm, scientists have had to become pioneers of remote sensing. They cannot simply go and look, they must rely on technologies that can see through the ice. Ice-penetrating radar, mounted on aircraft that fly in precise grids over the continent, sends radio waves down through the frozen layers. When these waves hit the bedrock below, or even layers of water, they bounce back, creating a detailed echo map of the subglacial world. It is a slow and painstaking process, like creating a massive continent-sized ultrasound image. Each pass of the plane reveals another sliver of the hidden landscape, gradually building a complete picture of what lies beneath. The results of these remote surveys have been nothing short of astonishing. They have revealed a landscape of epic proportions. There are vast basins, some of which lie more than 2 kilometers below sea level. There are winding canyons that would dwarf the Grand Canyon in both length and depth. The Bentley Subglacial Trench, for example, is one of the deepest points on Earth not covered by ocean. These discoveries have completely rewritten our understanding of Antarctic geography. Far from being a featureless dome of ice, the continent is a place of dramatic relief, a secret world with a topography as varied and complex as any other on Earth, locked away from sight for millions of years. This hidden geography is not just a relic of the past. It plays a critical role in the present. The shape of the land beneath the ice dictates how that ice flows. Subglacial mountains can act as pinning points, slowing the flow of glaciers, while deep, smooth valleys can become fast-flowing ice streams, funneling vast quantities of ice towards the ocean. Understanding this hidden topography is therefore crucial for predicting how the ice sheet will respond to a warming climate. The secrets buried beneath the ice are not merely academic, they hold the key to understanding the future of our planet and the fate of our coastlines around the globe. The greatest surprise to emerge from beneath the ice is not rock, but water. For decades, scientists believed that the base of the ice sheet was frozen solid to the bedrock below. The idea of liquid water existing in such a frigid environment seemed impossible. Yet, the same radar techniques that revealed hidden mountains also began to show strange, perfectly flat reflections deep within the ice. These reflections were too smooth to be rock. There could only be one explanation: vast bodies of liquid water trapped between the ice and the land. Antarctica, the driest desert on Earth, was hiding a secret watery underworld, a vast network of rivers and lakes that never see the light of day. This discovery was, honestly, revolutionary. Today, we know of more than 400 of these subglacial lakes, from small ponds to enormous bodies of water like Lake Vostok. Lake Vostok is one of the largest lakes in the world, comparable in surface area to Lake Ontario, yet it is buried beneath 4 kilometers of solid ice. The water within it has been isolated from the Earth's atmosphere for an estimated 15 million years. The immense pressure from the ice above keeps the water from freezing. while geothermal heat from the Earth's crust warms it from below. These lakes are not isolated ponds. They are connected by a vast network of hidden rivers, forming a continent-wide plumbing system that is constantly at work. This hidden hydrological system makes the ice sheet far more dynamic than we ever imagined. These lakes fill and drain over time, causing the ice surface above them to rise and fall by several meters. Sometimes a lake can drain catastrophically, sending a massive flood of water through the subglacial river system. These events can lubricate the base of the ice sheet, causing the glaciers above to accelerate their march to the sea. What we once thought of as a static, frozen block is in fact a continent in constant motion, its behavior profoundly influenced by the secret waters flowing in the darkness far below. The silent, frozen world is alive with movement. The existence of this liquid water in one of the most extreme environments on Earth immediately raised a tantalizing and profound question. If liquid water can exist here, sealed off from the sun for millions of years, could something else exist with it? Could life have found a way to survive in this cold, dark, high-pressure world? The possibility sent a ripple of excitement through the scientific community. The secrets beneath Antarctica were no longer just about geology and climate, they were now about the fundamental limits of life itself. The quest to explore this hidden world became a quest for life in the dark, with implications that reach far beyond our own planet to the icy moons of Jupiter and Saturn. To comprehend the scale of Antarctica's ice sheet is to grapple with a force of nature that, honestly, just defies everyday experience. It is a monument of frozen water so vast that it actually warps the very continent beneath it. In some regions, its thickness is over 4 kilometers, a vertical mile of ice accumulated over, well, countless millennia. The pressure at its base is immense, hundreds of times greater than the atmospheric pressure we feel at sea level. For centuries, this colossal shield of white led us to a simple, logical conclusion that the land below must be a flat, featureless plain, scoured into oblivion by the grinding weight of the ice above. It was a reasonable assumption born from the sheer impenetrability of the frozen veil. This assumption, however, has been shattered by modern science. The exploration of subglacial Antarctica is a testament to human ingenuity, a quest to map a world that no human eye will ever see directly. Scientists have become cartographers of the invisible, deploying an arsenal of advanced technologies to peer through the ice. The primary tool in this endeavor is ice-penetrating radar. Specially equipped aircraft fly back and forth across the continent in meticulously planned grids. With each pass, they send pulses of radio waves downward. These waves travel through the ice, bouncing off the bedrock below and returning to the aircraft, creating a detailed profile of the hidden topography, much like a ship's sonar maps the ocean floor. The process is painstakingly slow and methodical. Each flight line adds another sliver of information, another piece to an enormous continent-sized jigsaw puzzle. Over decades, these individual profiles have been stitched together to create a comprehensive map of the world beneath the ice. This is supplemented by other techniques, such as seismic surveys, which use sound waves to probe the deep structure of the rock, and gravity measurements, which can detect subtle variations in mass that correspond to hidden mountains and valleys. Together, these methods paint a ghostly but increasingly clear picture of a continent lost to time, a world that has been hidden from sight for longer than humans have existed. The resulting maps have been nothing short of a revelation, transforming our understanding of the seventh continent. The illusion of a flat, monotonous wasteland has been stripped away. In its place, we now see a land of breathtaking complexity and drama. The work of these remote explorers has revealed that Antarctica is not just a passive block of ice. It is a dynamic system where the shape of the hidden land profoundly influences the behavior of the ice above it. The quest to map this unseen world is not just an exercise in satisfying curiosity, it is essential for understanding the forces that shape our planet's climate and for predicting the future of our world in an age of rapid change. The images that have emerged from these remote sensing surveys are both alien and somehow strangely familiar. They show a world of epic proportions, a landscape sculpted by geological forces over hundreds of millions of years. and then frozen in time. Beneath the vast, seemingly uniform expanse of the East Antarctic ice sheet, the radar echoes have revealed a high, ancient plateau, a craton that forms the stable heart of the continent. But even more astonishing are the features found in the west. Here, the surveys have uncovered a series of deep basins, vast depressions in the Earth's crust where the bedrock lies more than 2 kilometers below sea level, a geography more akin to the deep ocean floor than to a terrestrial continent. Among the most stunning discoveries is a network of immense canyons carved into the bedrock by ancient rivers long before the ice arrived. One such feature, discovered beneath the Pine Island Glacier, is a chasm that would easily dwarf the Grand Canyon of North America. It stretches for hundreds of kilometers, its depths plunging to over 1.5 kilometers. These are not mere geological scars, they are superhighways for the ice. The smooth, deep floors of these canyons provide a path of least resistance, funneling ice from the continent's interior towards the sea at alarming speeds. The shape of this hidden world, carved in a warmer past, is actively dictating the pace of ice loss in our warming present. The discoveries are not limited to canyons and basins. The radar has also unveiled a tapestry of other features that tell a story of a geologically active and diverse land. There are vast, flat plains that were once likely the beds of ancient shallow seas. There are rugged highlands and clusters of hills that poke up into the base of the ice sheet. In some areas, the bedrock is so complex and fractured that it resembles a shattered mirror, a sign of intense geological activity in the distant past. Every new survey mission adds more detail to this incredible picture, revealing a continent far more intricate and varied than the uniform white blanket that covers it would ever suggest. This hidden topography is the critical missing piece in our models of ice sheet behavior. For years, climate scientists tried to predict how Antarctica would respond to rising temperatures, but their models were incomplete because they did not know the shape of the container the ice was in. Now, by incorporating this detailed subglacial geography, they can create far more accurate simulations. They can understand why some glaciers are retreating so rapidly while others remain relatively stable. The echoes bouncing back from this buried world are not just revealing a lost landscape. They are providing urgent warnings about the fragility of the ice and the future of our planet's coastlines. Of all the secrets uncovered beneath the ice, none is more mysterious or more unexpected than the Gamburtsev Subglacial Mountains. Discovered in the 1950s by a Soviet geophysical expedition, this mountain range lies near the center of East Antarctica, one of the most remote places on Earth. It is a range of staggering proportions, stretching for over 1,200 kilometers and boasting peaks that rise to 3,000 meters. These are mountains as jagged and majestic as the European Alps, yet they are completely invisible, buried under as much as 3 kilometers of solid ice. For decades, their very existence was a profound geological puzzle, a feature that seemed to defy the known principles of mountain formation. Typically, major mountain ranges are formed by the collision of tectonic plates, a process that generates immense heat and pressure. This heat should, over geological time, cause the mountains to erode and flatten. Yet the Gamburtsevs are ancient, believed to have formed hundreds of millions of years ago, but they retain the sharp, youthful peaks and deep valleys characteristic of a much younger range. It was a paradox that stumped geologists for half a century. How could such an old mountain range remain so uneroded and pristine? The answer, it turns out, was intimately connected to the very ice that concealed it from view. Intensive international research projects using advanced radar and other geophysical instruments have begun to unravel the Gamburtsev Enigma. It appears the range was born from an ancient continental rift, a place where the Earth's crust was stretched and pulled apart. This initial uplift was then preserved by a sudden and dramatic change in climate. Before the mountains had time to erode, Antarctica drifted over the South Pole and the ice began to form. The very first glaciers appeared in the high valleys of the Gamburtsevs, effectively flash freezing the landscape and protecting it from the erosive forces of wind and rain. The ice that hid the mountains was also their savior. This story of preservation provides a unique window into the past. The Gamburtsev Range is a snapshot of a landscape from a bygone era, a perfectly preserved relic of a world before the great ice ages. The ice sheet, acting as a colossal blanket, has kept the mountains in a state of suspended animation for over 30 million years. Studying this pristine environment gives scientists an unparalleled opportunity to understand the processes of mountain building and the exact conditions that led to the glaciation of Antarctica. The ghostly peaks of the Gamburtsevs are more than just a geological curiosity. They are a silent witness to one of the most profound climatic shifts in our planet's history. The ice sheet does more than just conceal the landscape. It acts as the world's largest and oldest time capsule. As snow falls and compacts into ice, it traps tiny bubbles of the atmosphere. By drilling deep into the ice and extracting long cylinders known as ice cores, scientists can analyze these ancient air bubbles and reconstruct a detailed history of Earth's climate stretching back nearly 1 million years. These cores reveal the planet's natural rhythms of warming and cooling, the cyclical dance of ice ages and interglacial periods. But the ice preserves more than just air. It also captures everything that falls upon its surface, from volcanic ash to meteoritic dust, creating a layered archive of planetary history. This frozen archive tells a story of a very different Antarctica. The continent was not always a frozen wasteland. Fossil evidence found in the few ice-free areas, like the Transantarctic Mountains, reveals a much warmer past. Fossils of ferns, beech trees, and even land animals show that tens of millions of years ago, Antarctica was covered in lush forests and teeming with life. It was part of the supercontinent Gondwana, connected to Australia and South America. The climate was temperate, even subtropical. This green world vanished when the continent became isolated at the South Pole, triggering a rapid plunge in temperature and the birth of the ice sheet that entombs it today. The subglacial landscape we are now mapping is a ghost of that warmer, greener world. The deep canyons were not carved by ice, but by powerful rivers flowing through ancient forests. The vast basins may have been home to great inland seas. When the ice began to spread, it advanced over this existing geography, preserving it like an insect in amber. The ice sheet is therefore a bridge between two worlds, the frozen, sterile Antarctica of today and the vibrant, living continent of the deep past. The shape of the land beneath the ice is a direct inheritance from that long-lost world, a topographical memory of a time before the cold descended. Understanding this transition is crucial. It shows us how profoundly and rapidly Earth's climate system can change. The onset of Antarctic glaciation was not a slow, gradual process. It was a tipping point, a sudden shift that permanently altered the planet. As we face our own period of rapid climate change, the story locked in the ice and the landscape it conceals serves as a powerful reminder of our planet's capacity for dramatic transformation. The secrets of Antarctica's past are not just ancient history. They are a vital lesson for our future, a warning written in a landscape that has been locked in time for 34 million years. Perhaps the most startling revelation from beneath the ice is not the presence of rock, but of heat. Antarctica is a continent of fire as well as ice. Hidden from view, a chain of volcanoes lies dormant and, in some cases, active beneath the western part of the ice sheet. More than 130 of these volcanoes have been identified, forming one of the largest volcanic regions on Earth. While a major eruption could be catastrophic, melting vast quantities of ice from below, the more immediate influence comes from the constant, gentle release of geothermal heat. This warmth from the Earth's interior creates a unique environment at the base of the ice, one that challenges the very definition of a frozen continent. This geothermal heat, combined with the immense pressure from the overlying ice, creates the perfect conditions for liquid water to exist. The base of the ice sheet is not frozen solid to the rock below, as was once thought. Instead, in many places, it rests on a thin film of meltwater. This discovery fundamentally changes our understanding of how glaciers move. This layer of water acts as a lubricant, decoupling the ice from the bedrock and allowing it to slide more easily towards the sea. The hidden volcanic and geothermal activity, therefore, acts as an engine, helping to drive the motion of the entire West Antarctic ice sheet. This subglacial melting is not uniform. It is concentrated in geothermal hotspots, creating a network of hidden lakes and rivers that crisscross the continent in the eternal darkness. These features, mapped by radar, show a world alive with hydrological activity. Lakes fill and drain, rivers flow, and vast quantities of water are transported beneath the ice. This hidden plumbing system is incredibly dynamic, and its behavior has a direct impact on the ice surface miles above. The sudden drainage of a subglacial lake can cause the glacier above it to surge forward, accelerating its journey to the ocean and its contribution to sea level rise. The interplay between the heat from below and the cold from above creates a complex and fragile system. As the climate warms, the surface of the ice sheet begins to melt more, and this surface meltwater can drill its way down through cracks and fissures, eventually reaching the base. This adds even more water to the subglacial system, further lubricating the flow of ice. The hidden engines of Antarctica, its volcanoes and geothermal heat, are being supercharged by a warming climate. The ice that conceals this fiery world is becoming increasingly unstable, and understanding these hidden processes is now one of the most urgent tasks in climate science. The discovery that Antarctica concealed a vast hidden world of mountains and canyons was revolutionary, but it was followed by a finding that was, in many ways, even more profound. For decades, the prevailing scientific consensus held that the base of the colossal ice sheet was frozen solid to the bedrock beneath. The sheer cold, penetrating kilometers deep, seemed to preclude any possibility of liquid water. Yet, as scientists refined their remote sensing techniques, strange anomalies began to appear in the data. The radar signals bouncing back from deep within the ice revealed features that were unnervingly flat and smooth, too perfect to be rock. There could only be one explanation, as improbable as it seemed: liquid water trapped in the darkness. This was the dawn of a new era in Antarctic science. The continent we perceived as the driest desert on Earth was, in fact, hiding a secret watery underworld. Today we know of more than 400 of these subglacial lakes, ranging from small isolated ponds to vast inland seas. These bodies of water exist in a delicate balance, a testament to the strange physics of this extreme environment. The immense pressure from the overlying ice lowers the freezing point of water, while geothermal heat, rising from the Earth's crust below, provides just enough warmth to keep it in a liquid state. This combination of crushing weight and gentle heat creates a stable environment for liquid water to persist in a place where surface temperatures can plummet below -80 degrees Celsius. These hidden lakes are not merely static pools. The same radar and satellite data that revealed their existence also showed that they are part of a dynamic, interconnected system. Scientists observed that the surface of the ice sheet above these lakes would rise and fall by several meters over the periods of months or years, clear evidence that the lakes were filling and draining. This led to the realization that they must be connected by a network of hidden rivers and channels, forming a vast, continent-wide plumbing system that constantly circulates water beneath the ice. The frozen continent, it turned out, possessed a secret circulatory system, pulsing with unseen currents in the eternal dark. The implications of this discovery are immense. This subglacial hydrological network acts as a lubricant for the entire ice sheet. The presence of water at the interface between ice and rock allows the glaciers above to slide more easily and rapidly towards the ocean. Far from being a static, passive block of ice, the Antarctic ice sheet is a dynamic entity, its movement profoundly influenced by the secret waters flowing far below. Understanding this hidden world of rivers and lakes is no longer a niche scientific curiosity. It is absolutely critical to predicting how Antarctica will respond to a warming climate, and what that will mean for the future of global sea levels. Among the hundreds of subglacial lakes discovered beneath Antarctica, one stands out for its sheer scale and profound isolation. Lake Vostok. Located deep in the interior of East Antarctica, directly beneath Russia's Vostok station, this is one of the largest and deepest lakes on the planet. It is immense, comparable in surface area to Lake Ontario in North America, and in some places its waters reach a depth of over 500 meters. Yet this colossal body of water is buried beneath nearly 4 kilometers of solid, ancient ice. It's, well, a world sealed off from our own, a pristine environment that has not been in contact with the Earth's atmosphere for an estimated 15 million years. A time capsule of staggering antiquity. The existence of Lake Vostok was first suggested in the 1970s by airborne radar surveys, but its true size and significance were not confirmed until the 1990s, when a combination of radar data, seismic soundings, and precise satellite altimetry painted a complete picture. The satellite measurements were particularly compelling, revealing a remarkably flat area on the ice sheet's surface that perfectly matched the outline of the lake deep below. The weight of the ice above is so great that it perfectly molds itself to the surface of the liquid water beneath it. This discovery captured the imagination of scientists and the public alike, presenting the tantalizing prospect of an ecosystem that had evolved in complete isolation for geological ages. The water in Lake Vostok remains liquid due to the unique conditions of its environment. The 4 kilometers of ice create a pressure more than 350 times that of our atmosphere, significantly lowering the freezing point of the water. At the same time, a gentle flow of geothermal heat from the Earth's crust warms the lake from below, keeping its temperature at a relatively mild -3 degrees Celsius. The ice sheet above also acts as a perfect insulating blanket, protecting the lake from the extreme cold of the Antarctic surface. This delicate thermal balance has maintained a vast body of liquid water in one of the coldest places on Earth for millions of years. The lake's long isolation makes it a truly unique scientific target. It is a world unto itself, potentially harboring a biological system that has been on its own evolutionary path for millions of years. Any life found within it would have had to adapt to extreme conditions: perpetual darkness, immense pressure, low nutrient levels, and high concentrations of dissolved oxygen. The prospect of studying such an environment is thrilling, as it could, redefine our understanding of the limits of life on Earth. Furthermore, Lake Vostok is considered the best terrestrial analogue for the ice-covered oceans believed to exist on moons like Jupiter's Europa or Saturn's Enceladus, making its exploration a sort of dress rehearsal for the search for extraterrestrial life. For a long time, the subglacial water systems were thought to be relatively slow-moving, with lakes filling and draining over many years or even decades. However, satellite observations have revealed a far more dramatic and powerful side to this hidden world. By tracking subtle changes in the elevation of the ice surface with incredible precision, scientists can actually watch the movement of water beneath the ice in near real time. In the late 2000s, this technology captured an event of astonishing scale, a massive, catastrophic flood that occurred entirely beneath the ice sheet. A group of interconnected lakes in East Antarctica was observed to drain suddenly, unleashing a torrent of water into the hidden river system. The volume of water involved was staggering. Over a period of just a few months, the lakes discharged approximately 2 cubic kilometers of water, a volume comparable to the flow of the River Thames in London over the same period. This immense pulse of water surged through the subglacial channels, traveling for over 250 kilometers before spilling into a new area and beginning to pool, lifting the ice sheet above it. The event demonstrated that the subglacial plumbing system is not just a gentle network of seeps and trickles. It is capable of channeling violent floods that can reshape the basal environment and have a dramatic impact on the ice flow above. These megafloods are driven by simple physics. As a subglacial lake fills with meltwater, the pressure of the water begins to lift the overlying ice. Eventually, the pressure becomes so great that it forces open a new channel or breaches an ice dam that separates it from a lower-lying area. Once a path is opened, the water begins to drain, and the friction of the flowing water generates heat, which melts the channel wider, accelerating the flow. This feedback loop can lead to a runaway drainage event, emptying a vast lake in a remarkably short period. It is a process that happens entirely in the dark, a hidden drama of immense hydrological power. The discovery of these subglacial megafloods has profound implications for ice sheet stability. The sudden release of vast quantities of water at the base of a glacier can dramatically lubricate its bed, causing it to surge forward at speeds many times its normal rate. As the climate warms and surface melt increases, more water may find its way to the base of the ice sheet through cracks and crevasses, potentially leading to more frequent and larger flood events. This could create a dangerous feedback loop where warming leads to more lubrication, which leads to faster ice flow, which in turn leads to greater sea level rise. The hidden floods of Antarctica are a powerful reminder of the dynamic and honestly sometimes violent processes at work beneath the ice. The intricate network of rivers and lakes beneath the Antarctic ice sheet is far more than just a collection of isolated features. It is a continent-spanning hydrological system, a hidden circulatory system that is fundamental to the continent's behavior. This subglacial plumbing is organized into vast drainage basins, much like the river systems on the surface of other continents. Water melted at the base of the ice in the high-altitude interior slowly makes its way through a web of channels and lakes, flowing ever downward and outward towards the coast. This system transports not only water but also heat and sediment, profoundly influencing the landscape it flows through and the ice it flows under. Mapping this hidden plumbing is a monumental task, relying on the combined power of satellite observation and airborne radar. Satellites track the subtle rise and fall of the ice surface, revealing the active lakes that act as reservoirs in the system. Meanwhile, ice-penetrating radar flown on aircraft can detect the faint signatures of the river channels themselves. These channels can be vast, some of them hundreds of meters wide, carving deep troughs into the soft sediment at the base of the ice. By piecing together these different lines of evidence, scientists are gradually building a comprehensive map of Antarctica's secret water world, revealing its complexity and its surprising efficiency. This hidden plumbing system makes the ice sheet incredibly sensitive to change. The shape and nature of the channels determine how quickly water can be evacuated from beneath the ice. In some areas, the water flows through a distributed network of thin films and small canals, a system that provides steady but limited lubrication. In other areas, however, the flow is concentrated into large, efficient river channels. These channels can transport huge volumes of water, effectively greasing the skids for the glaciers above them. These regions often coincide with the fastest flowing ice streams, the superhighways that discharge the vast majority of Antarctica's ice into the ocean. As our planet warms, this subglacial plumbing system is being altered. Increased melting on the surface of the ice sheet, particularly around its coastal margins, is introducing more water into the system from above. This meltwater can pour down through crevasses and moulins, reaching the bed of the ice sheet and adding to the volume of water in the hidden rivers. This extra water can overwhelm the existing drainage system, increasing lubrication and accelerating ice flow. The once hidden plumbing of Antarctica is now emerging as a key factor in the continent's contribution to global sea level rise, a critical link between climate change and the stability of the ice. The remote detection of subglacial lakes was honestly a triumph of geophysics, but it only raised more tantalizing questions. What secrets did these ancient isolated waters hold? Were they sterile, or did they harbor life? To answer these questions, scientists knew they would have to do something that had never been done before: drill through kilometers of solid ice to sample a subglacial lake directly without contaminating it. This challenge spurred the development of entirely new technologies and protocols as the scientific community recognized the profound importance of protecting these unique environments from contamination by surface microbes. It was, in many ways, an engineering challenge on par with a space mission. The primary target for many of these efforts was Lake Vostok, but its extreme depth presented immense difficulties. Other shallower lakes offered more accessible targets. One of the most significant breakthroughs came at Lake Whillans, a smaller active lake located beneath about 800 meters of ice in West Antarctica. An American scientific team developed a sophisticated hot water drill equipped with a filtration and sterilization system to ensure that nothing from the surface world would be introduced into the pristine lake environment. In January 2013, after days of continuous drilling, they finally broke through the base of the ice and lowered a suite of instruments into the dark water below. The moment of entry was a historic achievement. For the first time, humanity had gained direct access to this hidden realm. The instruments sent back immediate data on the water's temperature, pressure, and chemical composition. But the most eagerly awaited results came from the water samples themselves, which were carefully brought back to the surface for analysis. In laboratories around the world, scientists began the painstaking process of searching for any sign of life. The samples were filtered, their DNA was extracted, and individual cells were examined under powerful microscopes. The world held its breath, waiting for the verdict from this alien world beneath our feet. The results were astonishing. The water from Lake Whillans was not sterile. It was teeming with microbial life. The scientists found a diverse community of bacteria and archaea, numbering around 130,000 cells in every milliliter of water, a density comparable to some deep ocean environments. These were not dormant organisms merely surviving, they were part of an active, functioning ecosystem. This discovery was a landmark moment, providing the first definitive proof that complex ecosystems can thrive in the complete absence of sunlight, deep beneath the Antarctic ice sheet. The drill had not just reached another body of water, it had opened a window into a previously unknown biological world. The discovery of a living ecosystem in Lake Whillans confirmed what many scientists had long suspected, that life is, honestly, tenacious enough to survive even in the most extreme environments on Earth. The microbes found in the subglacial water were not feeding on sunlight through photosynthesis, like most life on the planet's surface. Instead, they are what scientists call chemotrophs, organisms that derive their energy from chemical reactions. They effectively eat rocks, metabolizing minerals like iron and sulfur that are ground up by the glacier's movement and washed into the lake. They live in a world of perpetual darkness, fueled by the slow, patient chemistry of the Earth itself. This discovery has, profound implications for our understanding of how and where life can exist. It demonstrates that the fundamental requirements for life are not sunlight and warmth, but simply liquid water, a source of energy, and a handful of essential nutrients. The subglacial environment of Antarctica provides all three. This realization vastly expands the potential habitats for life on our own planet, suggesting that deep, hidden biospheres may exist in other locations, such as within the Earth's crust. The life beneath the ice is a powerful testament to the sheer adaptability of biology, its ability to find a foothold in the most inhospitable of niches. The life found in Lake Whillans also provides clues about Antarctica's ancient past. Genetic analysis of the microbes shows that some are related to species found in the deep ocean. This suggests that the area now covered by the West Antarctic ice sheet was once a marine environment. When the ice sheet advanced millions of years ago, it likely trapped a population of marine microbes, which then had to adapt to a new life in the darkness of a subglacial lake. These organisms are living fossils, their DNA carrying the story of the continent's dramatic transformation from an open sea to a land of ice. Ultimately, the echoes of life from beneath the Antarctic ice resonate far beyond our own planet. The conditions in subglacial lakes, liquid water beneath a thick ice shell fed by chemical energy from a rocky core, are strikingly similar to what scientists believe exists on Jupiter's moon Europa and Saturn's moon Enceladus. These icy moons are now considered among the most promising places in our solar system to search for extraterrestrial life. The discovery that life can and does thrive in such an environment here on Earth gives us renewed hope that we are not alone in the cosmos. The secret world beneath Antarctica may be a blueprint for life on other worlds. Beneath Antarctica's ice, scientists discovered vast networks of liquid water, an environment once thought too extreme for life. Yet, extremophiles on Earth have shown us that life can thrive in boiling springs, acidic pools, and deep underground. Inspired by this, researchers drilled into Lake Whillans in 2013, retrieving water from 800 meters below. To their astonishment, the samples teemed with active, diverse microbes, proof of a thriving ecosystem in total darkness. This discovery shattered the notion of Antarctica as a dead continent, revealing a hidden living heart beneath the ice. The subglacial biosphere opened a new frontier, raising questions about the limits of life on Earth and beyond. Who are these organisms and how do they survive in such an improbable oasis? In the absence of sunlight, subglacial life relies on chemosynthesis, deriving energy from chemical reactions with minerals. As glaciers grind rock into glacial flour, water at the base interacts with these minerals, creating a chemical buffet for microbes. Some bacteria breathe iron, others metabolize methane or ammonium, forming a complex self-sustaining food web. These rock-eating microbes are ancient, revealing a shadow biosphere that predates photosynthesis. Studying them offers a glimpse into early Earth and suggests deep hidden biospheres may exist elsewhere on our planet. They are not just curiosities, they are a fundamental branch of life, thriving in the dark for eons. The Antarctic subglacial world is a testament to life's ingenuity. Life beneath the ice faces relentless cold, crushing pressure, and scarce nutrients. Microbes here are extremophiles, equipped with antifreeze proteins and flexible cell walls to survive freezing temperatures. Their enzymes and membranes are adapted to high pressure, and every aspect of their biology is fine-tuned for survival. Genetic studies reveal links to organisms in deep oceans and Arctic soils, hinting at ancient dispersal and resilience. These subglacial communities are not isolated. They're part of a global network of extreme survivors. Their DNA is a living record of Antarctica's transformation from a green world to one of ice. By studying them, we uncover the story of life's endurance through Earth's most dramatic changes. Scientists once believed only microbes lived beneath Antarctic ice shelves, but new discoveries proved otherwise. Cameras lowered through boreholes revealed ghostly animals, sponges, and mysterious filter feeders, thriving in total darkness, far from sunlight. These colonies exist hundreds of kilometers from open ocean, challenging our understanding of how food and energy reach such remote places. The source of their sustenance remains a mystery. Perhaps chemosynthetic microbes or distant ocean currents deliver enough nutrients. This ghostly fauna shows that the hidden world beneath the ice is far more complex than imagined. Each discovery rewrites our theories about life's possibilities in extreme environments. The Antarctic under-ice realm is still full of secrets waiting to be revealed. The presence of sponges and other animals deep beneath the ice shelves suggests a complex, interconnected ecosystem. ROVs have uncovered a surprising diversity: sea anemones, brittle stars, and ancient glass sponges, adapted to the cold, dark world. These creatures grow slowly, live long lives, and rely on senses other than sight to survive. Their existence challenges our models of polar ecosystems, revealing the ice shelves as unique, vital habitats. But these fragile communities are threatened by climate change and collapsing ice shelves. We must race to explore and understand this hidden biodiversity before it disappears. The under-ice world is a biological treasure at risk of vanishing before we fully comprehend it. The thriving ecosystems beneath Antarctica's ice have revolutionized our search for life beyond Earth. Icy moons like Europa and Enceladus may harbor similar dark, high-pressure oceans beneath their frozen crusts. The chemosynthetic microbes of Antarctica prove that life doesn't need sunlight, just water, rock, and chemical energy. These discoveries transform the search for alien life from theory to possibility, guiding future missions to distant worlds. Technologies developed for Antarctic exploration are paving the way for drilling into extraterrestrial ice. These secrets beneath the South Pole are not just about Earth, they're a blueprint for finding life elsewhere in the universe. Antarctica's hidden biosphere brings us closer to answering, are we alone? For millions of years, the Antarctic ice sheet has existed in a state of delicate equilibrium. The immense weight of snow accumulating in the continent's interior pushes the ice outward towards the sea, while carving icebergs and melting at its edges balance the input. This natural cycle has persisted through ice ages and warm periods, maintaining Antarctica as a vast, stable reservoir of frozen water. But this ancient balance is now being disturbed. The hidden world beneath the ice, with its secret rivers and mountains, is not immune to the changes happening on the surface of our planet. The entire system, from the highest plateau to the deepest subglacial trench, is now facing a profound and accelerating threat from a rapidly warming climate. The primary driver of this change is the warming of the global atmosphere and, even more critically, the oceans. The Southern Ocean that surrounds Antarctica is absorbing a disproportionate amount of the excess heat trapped by greenhouse gases. This warmer water is now coming into direct contact with the edges of the ice sheet, particularly with the floating ice shelves that act as crucial protective barriers. These ice shelves, which can be hundreds of meters thick, have historically acted like a cork in a bottle, buttressing the glaciers behind them and regulating their flow into the sea. Now, this warmer ocean water is eating away at them from below, thinning them out and weakening their structure. This process of basal melting is largely invisible from the surface, a hidden danger that is steadily undermining the continent's defenses. As the ice shelves thin, they become more susceptible to cracking and collapse. Huge fissures can propagate across their surface, and vast sections, sometimes the size of a small country, can break away in spectacular carving events. When an ice shelf disintegrates, the glaciers it was holding back are suddenly freed. The cork is removed from the bottle. With this buttressing force gone, the glaciers can accelerate dramatically, dumping ice into the ocean at a much faster rate and contributing directly to a rise in global sea levels. This is not a theoretical future scenario, it is happening now and at a pace that is alarming scientists. Satellite data collected over the past few decades shows a clear pattern of thinning ice shelves and accelerating glaciers, particularly in the western part of the continent. The fragile balance that has defined Antarctica for eons is beginning to unravel. The hidden world beneath the ice, once thought to be locked away and unchanging, is now being exposed to the forces of a new, warmer world. The secrets it holds are no longer just about the planet's past. They are urgent warnings about its future, a future that is being reshaped by our actions today. And while the entirety of Antarctica is feeling the effects of climate change, one region is of particular concern to scientists: the West Antarctic ice sheet. Unlike its much larger and thicker eastern counterpart, which rests mostly on high ground, a significant portion of the West Antarctic ice sheet is grounded on bedrock that lies far below sea level. This unique geography creates a fundamental instability. It means that the ice sheet is not just being melted from its edges, it is vulnerable to the intrusion of warm ocean water deep into its interior. This configuration, known as a marine ice sheet instability, makes it the soft underbelly of the frozen continent. Imagine a vast bowl, with the rim of the bowl at the coastline. The ice sheet fills this bowl, but the deepest part of the bowl is far inland. This is the situation in West Antarctica. The glaciers here flow out towards the sea, and their grounding line, the point where the ice lifts off the bedrock and begins to float, rests on a downward sloping bed. This means that as the glacier retreats due to melting at its front, its new grounding line is established in ever deeper water. A thicker cross-section of ice is then exposed to the warm ocean, which in turn increases the rate of melting. This creates a dangerous and potentially unstoppable feedback loop. This process is not just a theory, it is the driving force behind the rapid changes being observed in glaciers like Thwaites and Pine Island, often referred to as the Doomsday Glaciers. These two glaciers alone are responsible for a significant portion of Antarctica's current contribution to sea level rise. They act as drainage channels for a huge section of the West Antarctic ice sheet, and their retreat is accelerating. Scientists are racing to understand just how unstable they are. If a runaway retreat were to be triggered in this sector, it could lead to the collapse of the entire West Antarctic ice sheet over a period of centuries, a catastrophic event for global coastlines. The fate of this vulnerable region is one of the biggest and most urgent questions in climate science. The hidden topography beneath the ice, the deep basins and canyons carved in a warmer past, is now dictating the continent's future. The very features that make the subglacial world so fascinating are also the source of its greatest weakness. The warm ocean is probing these ancient channels, finding pathways to deliver heat to the heart of the ice sheet. The stability of West Antarctica, and the coastal cities around the world that depend on it, hinges on these hidden interactions happening in the dark, miles below the ice, at the critical interface between ice, ocean, and rock. The vast majority of Antarctica's ice is not discharged into the ocean uniformly. Instead, it is funneled into fast-flowing corridors known as ice streams. These are colossal rivers of ice, tens of kilometers wide and hundreds of kilometers long, that flow at speeds up to 100 times faster than the surrounding ice. They are the arteries of the ice sheet, responsible for transporting the bulk of the ice from the deep interior to the coastal margins. The behavior of these ice streams is a critical factor in determining the overall health and stability of the continent. And today, these rivers of ice are accelerating. The speed of an ice stream is controlled by what happens at its base. As we have seen, the hidden world of subglacial water plays a crucial role. A thin layer of water or water-saturated sediment at the interface between the ice and the bedrock acts as a lubricant, allowing the ice to slide more easily. The efficiency of this lubrication is the primary throttle on the ice stream's velocity. As the climate warms, this system is being fundamentally altered. Increased melting, both from the warm ocean below and from the surface above, is adding more water to the base of the ice streams, effectively greasing the skids and allowing them to flow faster. Satellite, laser and radar measurements have provided undeniable evidence of this acceleration. By repeatedly measuring the elevation and velocity of the ice surface, scientists can track changes with incredible precision. These observations show that many of the major ice streams in West Antarctica, and even some in the east, are speeding up. In some cases, glaciers have doubled their speed in just a couple of decades. This acceleration means that more ice is being moved from the land into the ocean every year, a direct and measurable contribution to rising sea levels. The ice sheet is, in effect, bleeding out faster and faster through these arterial routes. This acceleration is not just a passive response to warming, it is part of a complex feedback system. As the ice flows faster, it stretches and thins, which can lead to more cracking and crevassing on its surface. These cracks can act as conduits, allowing surface meltwater to penetrate deep into the ice, eventually reaching the bed and further enhancing the lubrication. This creates a vicious cycle. Faster flow leads to more damage, which leads to even faster flow. The great rivers of ice, once part of a balanced cyclical system, are now becoming one-way conveyor belts, driven by a warming world and relentlessly carrying the fate of our coastlines out to sea. While the primary threat to Antarctica's ice comes from the warming atmosphere and oceans, there is another, more ancient force at play. As we've discovered, Antarctica is a continent of fire as well as ice. A vast volcanic region lies hidden beneath the West Antarctic ice sheet, a place where the Earth's inner heat leaks out towards the surface. This geothermal heat has been shaping the subglacial environment for millions of years, creating the network of lakes and rivers that lubricate the base of the ice. For eons, this was part of a stable system. But in a warming world, this combination of fire and ice is becoming increasingly dangerous. The geothermal heat provides a constant source of melting at the base of the ice sheet, independent of the climate on the surface. This creates areas of weakness, places where the ice is already resting on a slippery bed of water. These are the very regions where the fast-flowing ice streams are often located. Now, as warmer ocean water begins to thin the ice from the edges, the insulating pressure of the overlying ice is reduced. This reduction in pressure could, in theory, make it easier for magma to move towards the surface, potentially increasing volcanic activity. A major subglacial eruption would be a catastrophic, albeit low probability event, capable of melting immense volumes of ice from below. Even without a full-blown eruption, the steady and uneven flow of geothermal heat creates a complex and unpredictable landscape at the base of the ice. It means that some areas are more prone to melting and sliding than others. The hidden geothermal hotspots can precondition the ice sheet for rapid change. When the pressure from a warming climate is applied, these are the areas that are likely to respond first and most dramatically. Understanding the location and intensity of this hidden heat flow is therefore crucial for predicting which parts of the ice sheet are most at risk of collapse. This dangerous synergy between internal heat and external warming highlights the complexity of the Antarctic system. It is not a simple case of ice melting in a warmer world. It is an intricate dance of interconnected processes where geology, hydrology, and climatology all collide. The fire beneath the ice adds a wild card to our climate projections, a source of uncertainty that makes the task of predicting the future of the ice sheet even more challenging. The ancient heat of the Earth is combining with the new heat of our altered climate, creating a potent and volatile mix that threatens to destabilize the largest single mass of ice on the planet. The changes happening in the remote frozen world of Antarctica are not a distant, abstract problem. They have direct and profound consequences for every person on the planet. The ice sheet is the largest potential contributor to global sea level rise, holding enough water to raise the oceans by nearly 60 meters. Even a small percentage of this ice melting would have a catastrophic impact on coastal communities worldwide. The fate of cities from New York to Shanghai, from London to Miami, is inextricably linked to the stability of the ice in this seemingly faraway land. The secrets beneath the ice are not just scientific mysteries, they are warnings of a future that is rapidly approaching. The current contribution from Antarctica, while still measured in millimeters per year, is accelerating. The rate of ice loss has tripled in the last decade alone. This trend is consistent with the worst-case scenarios projected by climate models, suggesting that we may be underestimating the speed at which these changes can occur. A rise of just 1 meter in global sea levels, a plausible scenario within the next century if emissions continue unabated, would displace hundreds of millions of people, inundate vast areas of fertile agricultural land and cause trillions of dollars in economic damage. It would, quite literally, redraw the map of our world. The potential collapse of the West Antarctic ice sheet represents a planetary-scale tipping point. Once the process of runaway retreat begins, it is believed that it would be irreversible on human timescales, locking in several meters of sea level rise over the centuries to come, regardless of any future efforts to reduce emissions. We would be committed to a future of perpetually rising seas. The decisions we make in the next few years will determine whether we cross this critical threshold. The ice sheet is sending us a clear signal. Its accelerating melt, a stark and unambiguous measure of the planet's distress. The story of Antarctica's ice at risk is ultimately a story about us. It is a reflection of the profound impact our industrial civilization is having on the fundamental systems of our planet. The hidden world beneath the ice, the mountains that steer the flow, the rivers that lubricate it, the heat that melts it from below, is being pushed out of balance by our actions. The silent, frozen continent is speaking, not in words, but in the universal language of physics. It is telling us that our world is changing and that the consequences of our inaction will be felt on every coastline on Earth. The question is no longer whether we can hear it, but whether we will choose to listen. Antarctica, the continent we once thought of as a lifeless, static wasteland, has revealed itself to be a world of profound and unexpected wonders. We have journeyed beneath its colossal ice sheet, a veil of white that conceals a realm of staggering complexity. We have discovered a lost landscape of epic proportions, a secret geography of mountains taller than the Alps and canyons deeper than any on the surface of our continents. This is a world locked away for millions of years, a ghost of a warmer, greener past, perfectly preserved in a state of suspended animation. The illusion of emptiness has been shattered, replaced by the breathtaking reality of a hidden continent. A final frontier, not in some distant galaxy, but right here on our own planet. This hidden world is not just made of rock, it is alive with water and heat. We have found a vast continent-spanning network of hundreds of lakes and rivers, a secret plumbing system that pulses with unseen currents in the eternal darkness. We have discovered the ancient warmth of the Earth itself, with geothermal heat and a chain of volcanoes, creating the conditions for liquid water to exist in the coldest place on Earth. This dynamic interplay of fire and ice drives the motion of the glaciers above, demonstrating that the continent is not a solid, frozen block, but a living, breathing system constantly in motion. its behavior dictated by the powerful forces at work in its hidden depths, and in this dark, watery realm we have found life. Against all odds, in the crushing pressure and absolute blackness ecosystems thrive. We have found microscopic organisms that eat rocks and breathe minerals, their existence powered not by the sun but by the raw chemical energy of the planet. We have even found complex animals, ghostly sponges and other mysterious creatures clinging to life on the seafloor hundreds of kilometers from the open ocean. These discoveries have redefined the very limits of where life can exist, suggesting that the universe may be far more hospitable to life than we ever dreamed, with the hidden world of Antarctica serving as our guide. This journey beneath the ice has been a profound lesson in humility. It has shown us that even in the 21st century, our planet is still full of fundamental mysteries and astonishing secrets waiting to be uncovered. Antarctica has reminded us that there is always more to learn, that our assumptions are often wrong, and that the world is a more complex, dynamic, and wondrous place than we can possibly imagine. The silent continent has revealed itself to be a treasure trove of scientific knowledge, a natural laboratory for understanding the history of our planet, the tenacity of life, and our potential place in the cosmos. The age of exploration is far from over. It has simply moved beneath the surface. Yet, for all its wonder, the story of Antarctica is also a story of profound fragility. This hidden world, so perfectly balanced for millions of years, is now being destabilized by forces originating thousands of miles away. The heat from our industrial civilization, trapped by greenhouse gases, is relentlessly warming the oceans. This warm water is now creeping into the most vulnerable parts of the continent, eating away at the ice from below, thinning its protective shields and awakening the sleeping giant. The ancient rhythms of the ice are being disrupted, and the consequences of this disturbance are beginning to ripple across the globe, reaching every coastline on Earth. The hidden geography we have discovered is not just a geological marvel, it is the blueprint for the continent's potential collapse. The deep basins of West Antarctica, which place the ice sheet in direct contact with the warming ocean, create a terrifying vulnerability. The great subglacial canyons carved by ancient rivers now serve as superhighways that channel warm water inland and funnel accelerating glaciers out to sea. The very features that make Antarctica so scientifically fascinating are also the source of its greatest peril. The continent's distant past is colliding with our present, creating a future of unprecedented and dangerous uncertainty for all of humanity. The ice is not just melting, it is sending us a message. In its accelerating retreat, we see a direct and unambiguous measure of our planet's fever. The changes happening in this remote and desolate place are not an isolated phenomenon. They are a mirror reflecting the global consequences of our collective actions. The rising tide that begins with a drop of meltwater in Antarctica will not stop at its shores. It is a warning that will arrive in our harbors and on our doorsteps. A slow-motion catastrophe that will reshape our world, displace millions, and challenge the very foundations of our societies. The fate of our coastal cities is being written in the thinning ice of the South Pole. What happens in Antarctica does not stay in Antarctica. This simple truth is perhaps the most important secret the continent has to share. We are all connected to this remote, frozen world. Its stability is our stability. Its future is our future. The hidden rivers, the buried mountains, and the ghostly life forms are all part of a single interconnected Earth system, a system that we are now pushing beyond its limits. Antarctica is the canary in the coal mine for our planet, and its song of alarm is growing louder with each passing year, a clear and urgent call to a world that has been too slow to listen. The secrets emerging from beneath the ice present us with a stark and unavoidable choice. We are the first generation to understand the full scale of what is hidden in Antarctica, and the first to witness the profound threat it now faces. We are also the last generation with the power to prevent the worst consequences of its potential collapse. The knowledge we have gained is not just a source of wonder, it is a profound responsibility. We can no longer claim ignorance. The science is clear, the warnings are unambiguous, and the evidence is etched into the accelerating retreat of the ice itself. The future of this pristine continent, and in large part our own, rests squarely in our hands. The path forward requires immediate and decisive action on a global scale. We must transition away from the fossil fuels that are warming our planet, embracing clean and sustainable sources of energy. We must work together as a global community to reduce our emissions and stabilize our climate. This is not just an environmental issue, it is the great economic and moral challenge of our time. Protecting Antarctica is not about saving a remote wilderness for its own sake. It is about preserving the stability of the planetary systems that allow our own civilization to thrive. The cost of inaction is immeasurably greater than the cost of action. At the same time, we must continue to explore and to learn. The race is on to understand the intricate processes at work beneath the ice before critical tipping points are crossed. We need to support the scientists who are working on the front lines of climate change, deploying new technologies to monitor the ice, to map its hidden depths, and to decipher its final secrets. Every new piece of data, every new insight helps us to refine our predictions and prepare for the changes that are coming. Our curiosity and our quest for knowledge are among our greatest tools in navigating the challenging future that lies ahead. Antarctica is speaking. It speaks in the thunderous crack of a calving glacier, in the silent flow of its hidden rivers, and in the accelerating pulse of its great ice streams. It tells a story of a planet more wondrous and more interconnected than we ever knew. But it also tells a story of a world on the brink of a profound and irreversible transformation. It asks us if we are willing to listen to its warnings, to respect its fragility, and to act with the wisdom and foresight that our knowledge now demands.